Welcome to the Passion for Technology podcast. In this episode, we're diving into an article from our latest TQ magazine, exploring the fascinating world of human-machine interfaces. For more details, interesting insights, and valuable infographics, be sure to check out the show notes. Robust HMIs for harsh environments. Whether in the rough daily routine of construction machinery, in food production, or as a public terminal in the city, human-machine interfaces are often exposed to extreme environmental conditions. By using qualified materials and appropriately designed constructions, and choosing suitable operating technologies, HMIs can work reliably even in the most adverse conditions. Traditional mechanical buttons, which are operated by actual touch, are robust components, but germs or impurities can easily settle on mechanical and moving parts. Moreover, they cannot be installed flush in plants, an additional gateway for dust and the like. A resistant and hygienic alternative is provided by capacitive buttons. They can be integrated flush into any system and have no mechanical elements where dirt particles or germs can settle. Thus, sealed, smooth, and easy-to-clean user interfaces are possible, preventing the ingress of moisture or dust. Elastomer keyboards offer a high-quality, tactile feel with an underlying switch layer. They are characterized by high weather resistance in harsh environments and moisture and chemical resistance. Elastomer keyboards are used when three-dimensional buttons are needed in environments with high moisture, such as in maritime or defense applications. In the food, laboratory, and medical sectors, the membrane keyboard plays an important role due to its closed surface, resistance to chemicals, and its imperviousness to liquids and dust. The classic membrane keyboard consists of about 8 layers, of which only the top layer, the front foil, is visible in the later application. The actual switching element, the snap disk, is placed between the different layers and is thus well protected against dust and moisture. Integrated acrylic inlays also prevent deformation of the snap disk. In harsh application areas, touch panels should be equipped with scratch-resistant and shock-insensitive surfaces and components. They must withstand high stresses from jet water, steam, and dirt, and be sealed against harmful gases. The entire surface of the input system must be resistant to oil, solvents, and aggressive chemicals. Touch panels should meet the IP67 protection class and have a continuous, closed front structure without dirt edges. This facilitates cleaning, which is of great importance in the food industry, for instance. The robustness against mechanical stresses can be ensured by choosing hardened glasses. In conjunction with a laminated composite glass pane on the back, for example, vandal-proof touch panels for public applications can be realized. Capacitive PCAP touch technology meets both industrial and medical requirements. It is resistant to water and saltwater, electromagnetic radiation, and chemicals. Moreover, it can also be operated with gloves and can be equipped with antimicrobial surfaces. With antimicrobial coatings, HMIs are also equipped for particularly high hygiene requirements. Generally, a distinction is made between active and passive materials. Passive coatings prevent microbial colonization through the surface structure alone. The so-called lotus effect inhibits the adhesion of microorganisms to the material surface. In contrast, active antimicrobial materials contain biocidal components that attack microorganisms at the cell wall, in metabolism, or in the genome. To meet high hygiene standards, it is recommended to provide switch handles and user interface for touch applications with coatings with log reduction values of 5.25 disinfection to 6.05 sterilization. Vibrations, extreme temperatures, and chemicals affect not only the surface of a human-machine interface. HMI assemblies generally consist of a multitude of layers or components. Adhesives and sealants ensure that thermal and electrical contacts remain consistently connected, possible damage from overheating is prevented, and HMIs are protected from short circuits, contamination ingress, or mechanical failure due to vibrations. For example, display layer bonds must have adequate peel adhesion, shear strength, and impact resistance under harsh environmental conditions. Furthermore, vibration and shock absorbers and seals are indispensable components of HMI design. Thin and lightweight foams absorb vibrations and shocks very effectively and are flexible enough to fit into predefined housing dimensions and consider temperature change, swelling, and contractions. All these materials must not lose their function in harsh conditions, for example, by contracting, drying out, or outgassing at extreme temperatures. Accordingly, careful attention should be paid to the materials for adhesives, seals, and co. when designing an HMI for harsh environmental conditions. We hope you enjoyed this episode. For more in-depth information on the latest trends and technologies in human-machine interfaces, check the show notes to access the latest TQ magazine, available free of charge.